Hi, good morning, everyone. Senthil, we will just start now. I think a few participants will continue to join, but meanwhile, I'll just give a basic introduction to everyone and then we'll start the session. Hi, everyone. Good morning. Thank you so much for joining. So, today we have with us Mr. Senthil Subramanian, who's part of Cognizant, and we will be talking about enterprise Gen AI today. I just want to give a brief introduction about the program and the speaker before we start the session. So, as some of you might be knowing, this is our fourth session in the series. We have been doing this from February, and we will be continuing to do this program throughout the year. This program aims to help colleges and professors understand what is the industry perspective and take it back to their colleges and students, especially so that the future generation of students come out with understanding of the perspective of the industry and how technology is shaping up. That's a brief introduction about the program. Talking about Senthil has been with Cognizant for 25 years now. He's an industry stalwart. He's the CTO of Cognizant's global growth markets. He primarily focuses on long-term technology strategy, processes, and industry relationships. He leads motivated teams of enterprise and technology architects to deliver business value and client success. Primarily, his technology interests are in machine learning, high performance computing, and cybersecurity. He also holds a patent in applying conversational AI in resilience engineering. And he was featured in 23 of 2023 Tech Pioneers and CTOs Building the Future of Technology by HRAI. I would also like to mention that from nasscom, we have been engaging with Senthil for quite some time, and he's a leader and he's a person who was looked to for various things, especially in technology sector. And he's also worked in various verticals in product engineering and in multiple verticals. So anything related to technology, you can please ask him throughout the session. If you have any questions, please drop your questions in the Q&A or in the chat so that at the end of the session he can address that. um, and today he will be talking about Gen AI, few architectures and fine tuning of concepts, and especially he will be focusing on industry use cases, which I think will be very interesting to hear from Cognizant's perspective because they have been pioneering in innovation right now. Over to you, Sindhu.
Thanks, Kavya. Thanks, everyone, for joining this session. And we will focus today on generative AI. I'll talk briefly about the evolution from our perspective, and we'll also walk through some of the history of how it evolved, what are the architectures, and also some use cases which we feel is relevant to multiple industries. And then also I'll leave you with some thoughts around how to architect systems, not just applications using generative AI. So with that, I will probably start. Let me share my screen. Is my screen visible, Kavya?
Yes, sir.
Oh. Okay. I love this particular law, right? So people tend to overestimate the short-term impact of new technologies while underestimating their long-term effects. This is very true in the sense, lot of trends which happen in the technology industry. For example, you can take a simple example of cloud, right? Initially, a lot of our customers and ourselves, we thought, why cloud? There's a lot of security concerns. Who will adopt? How will I put my data on the cloud, etc., etc. So there was a lot of this concerns and also some amount of overestimation, right? So that's short term, but for the long term, if you look at 10 years from then now, right, there's a lot of adoption, a lot of impact. Everybody's on the cloud. So this necessitates that there are some trends, for example, cloud and now generative AI. You should This law still holds good, right? So you should not overestimate the short-term impact, but you'll have to also be conscious of how to consciously invest and understand the value of the long-term presence of these trends. So with that, we from an AI perspective, we see this seven different patterns. Some of them you already know as academicians. The traditional AI, right? So we always talk about things like predictive analytics, machine learning, anomalies, all those stuff. But what is happening in the near term is there is a lot of customer focus, I would say, from a personalization angle, from understanding the customer in terms of course, the customers are humans themselves, right? Understanding their intent, understanding their patterns and behaviors, and also systems which can think on their own, act on their own, basically autonomous and goal-driven systems. So these are seven patterns which we see. Some of them are already existing, some of them are evolving like autonomous and goal-driven systems. Just taking a step back and trying to differentiate between what we call as traditional machine learning, artificial intelligence, and generative AI. So artificial intelligence as a science has already been there. It's been there for decades together. I myself have studied some textbooks when I was in college 3 decades back. But in essence, in today's world, what artificial intelligence generally means is mimicking the human behavior, right? So systems which are able to perform any task which typically require human intelligence or beyond is now called AI, and that requires different technologies, techniques, and even some strategies to mimic that specific human intelligence across a wide range of systems, industries, and applications. While traditional machine learning, as you all probably know, that it's more about making predictions, more of a statistical background, right? So my one of my bosses earlier used to say is statistics is about looking backward and probability is looking forward. So it's a combination of both, I would say, from a traditional ML perspective. Generative AI is also not new, but earlier, probably 5 6 years back, we always talked about natural language processing, natural language generation. That particular field has evolved very quickly, and we see a lot of these new age models generating a lot of things, including data, voice, text, video, whatever you want, right? And I will show some examples where in the industry we are talking about things like generative chemistry applied in the life sciences world, and so on and so forth. So just to set some context on this evolution, from an enterprise, from a customer angle, we see this 5 big areas of impact. I would say the first big area of impact is sales and marketing, because we can create a lot of content, whether it is media, whether it is social campaigns, whether it is sales content, or even virtual assistants who can directly talk to specific customers. Good example is retail chatbots, right? So even I was traveling last week uh, in Indigo specifically. They have rolled out one virtual assistant called Ask AI, right? We can ask questions like, what is my baggage limit? When is my flight departing? Things like that. Earlier, it used to be very nonsensical or non-contextual, right? So the assistant would not respond properly or would not understand my intent. I could not hold the conversation for a longer time. But now these, especially in the sales and marketing and customer support area, a lot of these virtual assistants have become more and more AI-like. They are mimicking human intelligence, and it's more fun to actually converse with those assistants. So that is one big area. The other area is, of course, IT and engineering. Our industry, the IT industry, is undergoing a massive change. Every customer, every project of ours is looking at how we can employ these generative AI tools for across the life cycle. I'll show you the full life cycle later, but simple things like writing test cases, generating snippets of code using the likes of Copilot, even actually automating things in production. So those are activities which are getting automated with generative AI. And of course, a lot of operational work, things which used to be very mundane, time consuming, operation intensive, those tasks are also getting, I would say, quote unquote, automated with generative AI. There are lesser areas, but very interesting domain intensive areas like risk, legal, and also R&D. When I say R&D, there is R&D applied across different industries. One good example, as I said before, is on the life sciences industry. We work with major pharma clients both in India as well as abroad, uh, in good areas like drug discovery, for example. Earlier, we had applied deep learning to discover new molecules. Now, with the advent of generative AI, we can even predict, not only predict, but annotate and do a lot of things in protein folding, things like that, right? So anything to do with R&D is also being applied in this particular area. And not to leave out risk and legal, so you would probably know that GPT-4 passed the bar exam. Since there is a lot of content, a lot of text, and a lot of understanding around the legal parlance, that is another ripe area for generative AI adoption. So that said, there are a lot of challenges, a lot of biases, a lot of concerns. If you go back to the Amara's law, right, that initial overestimation and concerns around a particular trend or a technology, which is valid now, especially since there is a lot of impact around the future of workforce. So things like generative AI itself, the output it generates can be totally wrong, and it could actually hallucinate and give output which might cause some factual harm. There are not enough controls, filters to catch that inappropriate content. There are systemic biases. Biases could stem from the fact that the data with which the model was trained, for example, if it's trained on a English corpus in a Californian background, it could not understand the nuances of a particular culture, for example, our culture, right, in Tamil Nadu, for example. So those biases still need to be addressed. But there could be areas where even intellectual property gets violated, right? So there are now lawsuits against some models. They have stole you have stole my content, and how do you reuse that? All that challenges are there. There are even this big area around how do you understand a individual organization or even an individual's values and norms, right? So how do you confer to that? That is a big area of both challenge and an opportunity which we are working on. So moving on, this is a interesting report from McKinsey which was published last year. So again, you can see the ones on the top, things like sales and marketing, software engineering, R&D, customer operations. So those are the areas which are getting impacted. This chart gives you a flavor of how much spend is impacted. Let's say if sales and marketing has a budget for a particular year, how much percentage of that budget is getting impacted is not showing how much revenue will get generated, but how much impact, how much they will invest in this particular technology across different functions of sales and marketing, software engineering, etc. And if you see on the right hand side, these four are the major broad fundamental use cases, if you will. One is, of course, content, anything to do with content, whether it is text, video, or anything along that space. Content summarization. So if you have a big, let's say, research article, an academic book, if we can summarize and then glean some insights out of it, that's a good use case. We often use it now because we have uh, implemented Microsoft 365 Copilot, etc., across our organization. So we use it heavily for a task like if there is a meeting going on. For example, this meeting now, if you had used Teams, for example, we could summarize what I had talked through, and then we can glean some insights. There are also applications of code generation. So as I briefly talked about in our software engineering work, and the very fundamental task of information retrieval and knowledge management using techniques like semantic search, augmenting semantic search with generative AI technologies are another good fundamental areas of applications. So let's look at some of the timelines of the evolution. So it's a brief timeline I'm showing here, right from 2020 to 2023. So you can see the plethora of models which have come about, starting from GPT-3 to Palm to GPT-4 to Grok. Now, with you would have seen the latest models from Google I/O and even OpenAI, right? The ones which are pretty fantastic to look at. They can basically converse in a multi-human scenario and then understand the intent, make jokes, make poems, things like that. So that space is evolving pretty fast, much faster than we had expected. And if you look at again a timeline view of the different dimensions of content, text, code, images, video, gaming, etc. So you would see focus on the green side, right? So the beyond 2023, 2024, so you would see more richer, more relevant, more contextual content being produced, generated, and also leveraged. So that would mean two things. One is your work, whether you're an academician or an industrialist or a student or a traditional worker working in any industry, so your work will get impacted, right? In both in positive and negative terms. You can either use it as a tool to augment your work, or you can view it as something as a uh, as an enemy type of a thing, which can probably affect your work. So it's about how you leverage this expertise which is available out of the box. Of course, there are concerns which I talked about earlier, but more and more you will get content which is more original, more immersive, more contextual. So that's gonna be prime time probably in another. I'm saying 5 years, but maybe it will happen in another 2-3 years from now. I know probably you know more than me from an academic angle, but I will try to reconstruct what has happened in the evolution space for Gen AI. So we have these vector databases, which are not new, which have been there probably for another 2 decades in making. Vector databases are nothing but databases which store vectors. So we all of us know what a vector is. So we can use vectors for understanding similarity. There are different measures like cosine similarity, Manhattan distance, etc., etc. So we can measure the range of similarity across various things, right? So it could be images, it could be content, it could be anything in the world. It basically is an n-dimensional vector which is stored in the vector database, and we store these vectors, create these vectors using embedding models, which are slightly new in this world. We'll talk about that. And then what has changed? So we have tons and tons of data, which if in a typical enterprise, for example, I'll take an insurance domain, right? So all the claims and policies which has existed for past 30 years, they have a mandate to store that information with all the changes it goes through, even simple things like a life event. For imagine the number of individual data records which are there. So that is in the order of petabytes. So we store that, our customers store that data, and the compute evolution has also been accelerated. So with the likes of both the hardware in terms of the GPUs and analog computing, and also from the models, right? So from traditional neural networks to deep learning networks to now this transformer architecture. So these three put together has provided a jumpstart to this generative AI era, I would say. The transformers are nothing but a way of constructing these deep learning networks. So essentially, they take in sequences of anything, which could be text or now even video. And internally, they have this encoder decoders, which continuously churn the input sequence and try to match it with the output probabilities. They are essentially probabilities which are being thrown out. But what is interesting is there is focus and attention, something called as a multi-headed attention to the hidden features, right? The hidden vector space. So that, for example, if you take a piece of text, earlier these sentence models would look at a word before and after to understand the context. But now, if you take a particular phrase or a sentence, the whole input sequence or the entire content is looked at for attention. So the context is more meaningful, and the output probabilities are even more contextual. So that is the essence of the transformer model. And I like this particular slide because this is from a web series I watch regularly called Suits. It's a legal web episode. And attention is all you need, is the key phrase, right? So the attention is nothing but how the model is very attentive to the input sequence as well as to the output probabilities in terms of what the end user expects. So there is a lot of human alignment, which was not there earlier. And with this single goal based objective, these models have succeeded pretty quick. And you would have experienced it yourself. So chatting with somebody, something like a chat GPT or any other model, right, is more meaningful now. So you can engage a chatbot for more than, I myself have used it for publishing papers of course, in our industry, to get content, to summarize, to paraphrase, do a lot of things, all the while immersing myself for more than 4 hours, which was never possible. And the simple truth is there is a lot of alignment, right? There is a lot of human alignment with the user. And let's look at the techniques used for constructing these GPT models. So GPTs are generative pre-trained, preordained transformers. Someone likes to call it preordained. So what essentially it does, that the techniques do, is they take a trained large language model, and then they also use a reward model, and use some repeated the transformer architecture which I talked about, right? It does repeated encoding decoding to align with the reward model using a human feedback model. So what used to be earlier pure reinforcement learning in isolation has been done in combination, and that technique has been used in combination with a large language model and a transformer to produce this fine-tuned uh, large language model, which you all now use and leverage, right? So not there are other types of architectures also, so which are evolving. So I don't want to dwell into too much detail into all the different types of architectures which evolve. But now, in if you peel the onion, so to speak, and see inside these different models which exist, it's not just a pure transformer model. There is all these existing models also. In combination, they produce good output. Things like GAN and variational or autoencoders, etc., etc. Right? And this space is evolving. This is not a one-stop pit stop. There are newer architectures which are evolving also. So I'll talk about some of the hardware architecture also later in this slide. Okay, let's move away from the academic angle and look into what applications are out there for generative AI. So as I said, it's just a world of probabilities, and the probabilities are more aligned. And this particular illustration explains it very simply, right? So for example, I don't want to eat a carpet, but I want to eat a tomato. So the probability is more well defined now because of the corpus of data which is being used. So the entire gamut of World Wide Web and lots of customized data from a lot of different users are embedded now as vectors, and then that is getting used. Different weights are used in the large language model. So the probability is close to one now, right? So whatever you want to hear, you're hearing now out of a large language model. You might think it is just, it doesn't have any intelligence, it's just blurting out these probabilities, but you will, whatever you feel is more human like. So you're able to see that difference now. Again, there is this LLM at the center, but there are a lot of peripheral activities which have to be done. So one initial step, typically, which is done is you do a pre-training, and then you do fine-tuning also in the context which you want. You might have a large language model you might want to fine-tune it to your context, to your data, and you would want to build a chatbot overlay to sometimes understand the human intent, get feedback to the chatbot, and then feed it to the LLM again, do some fine-tuning, and that is taken as output for future utterances, future inferences, etc. So should we break for some questions, or should I move forward, Kavya? I think I've thrown in a lot of content here.
So far, we have not received any questions in the chat or the QA section, Senthil. So you can
Okay.
continue. I would still, I think there's someone raised a hand. I'll just allow them to speak. Hi,
Sure.
Shripriya. Hi, Shripriya. If you're available and you are looking to ask some question directly to Senthil, please feel free to ask now. Okay, I think they might have raised by mistake, Senthil. You can
Sure.
continue. If you can, if anybody has a question in between, we'll take it, Senthil.
All right, thank you. So I will talk more about the enterprise context from this point on. So the way we look at enterprise systems, the technology stack which we leverage for building generative AI infused systems or something similar to this. We have, if you look at the layered architectural stack, a logical stack, the base is all infrastructure, right? Whether it is cloud provider, a hyperscaler providing an IaaS or a PaaS environment. There are also these AI chip vendors. There could be predominantly companies like NVIDIA providing GPU, and there are some new age analog chip vendors. We'll talk about them in detail later, which can do fast inference, right? And we have some measures, etc., how many tokens per seconds are generated, etc., etc. So that is the base. And above that, we have these LLMs, which are either commercial models, the like of OpenAI, the likes of Google Gemini, the likes of Microsoft's models, things like that. And there are also these open source models, like, for example, Llama, Mistral, so on and so forth. So these models are hosted in model hubs. The biggest one is Hugging Face. We leverage a lot of these model hubs, and we can even customize these models, fine tune these models. If we don't want a big model, we can take a portion of it, deploy it, extra. And on top of it, there's a lot of engineering work which needs to be done. It's not that we just bring in a model and then that will serve the purpose. We'll have to do a lot of API development. We'll have to instrument, do something called LLM ops. We'll have to make sure that whatever we develop as an API sits well in a production environment. It's able to produce reliable, consistent, performant output. For that, we'll have to instrument with a lot of measures, instrument monitoring tools, etc. So that's the engineering part. On top of it, we build both vertical and horizontal labs. So when I say vertical is all about the industry. It could be in our company, we have 4 different verticals. We have BFS and banking, financial services, insurance, healthcare, pharma. We have products and resources, which all the physical industries, manufacturing, retail, and we have the interesting communication media vertical, which is all about content again. And then there are horizontal labs also. Horizontal labs could be something like a chatbot. It could be let's say, a text generation app. It could be something in the scientific domain, looking at scientific literature, things like that, right? There's a lot of this cross-functional labs which can be generated. Even we are building apps, for example, recruitment, right? To understand the candidate's behavior, the candidate's intent, things like that. So those are horizontal labs. So this is a logical stack for you. And from a tech standpoint, of course, as I said, from a hardware standpoint, there is a lot of this GPUs and cloud and models, examples of so many models. This slide is a little bit outdated. A lot of models to choose from. That itself is a lot of work, right? So how do you pick a model which is suited to you, to your context, to your line of work? That's one challenge, and there is a lot of work there. So don't probably imagine that while generative AI is here, while a lot of work is getting automated, and then there is a real threat to engineering. The positive side is, like cloud, more work will get generated. So there's a lot of this work which we do, and even building applications on top. That is not something which will go away. So we will still build a lot of interesting, probably large scale applications using these technologies. And especially from a coding standpoint, we leverage a lot of these copilots. We use them day to day in our line of work. Things like Copilot, Tab9, and Code Whisperer, things like that, where we are using it to automate some of these mundane tasks which are essential, but things like test case generation is a good example, right? Nobody wants to write a unit test case, but that itself can be generated automatically using Copilot. And of course, documenting the code and probably production releases. These are things which can be done with Copilots. Okay, from a use cases standpoint, this is probably more interesting, right? This is across different industries. I'm not picking a particular industry. I can give examples by industry, but if you look at these dimensions of customers, employees, process, operations, supply chain, digital marketing, and admin ops, if you put everything together in a matrix. So from a customer standpoint, we always talk about customer advisory, what products are relevant, how do you sell to a customer, right? And from a internal facing thing, right, what is being done as a back-end work, A lot of this operational work around marketing, contact center is a good area. So anything, we do a project for a pizza company called Papa John's. So a lot of our work gets done out of Manila. There are 1,000 people sitting and answering calls to pizza orders, things like that. So there is a lot of call center knowledge, call center assistance, which can be automated. Things like sentiment analysis, speech to text is a good area, which can be easily done with generative AI. And anything to do with decision making or knowledge based work, right? For example, field work, if there is a lot of let's take a good example, right? If there is some road work happening or some TNEB work happening, how to actually assign the incoming work to a particular field force and then educate a newer workforce on that particular set of technologies. That itself is a good prime area for generative adoption, fundamentally because there is a lot of content to be consumed and understood. And if you take in the academic space again, if you think we can build per uh, course an LLM and then make it available for students, that is another good example, right? For new students to consume that knowledge and then uh, make that learning process a little bit better also. And the third area is around process and operations. A lot of, as I said, a lot of this mundane work which happens in the traditional business operations space. We earlier used to call it BPEO. Now we call it business operations, and we call it now even intelligent operations now. Basically, the human work is augmented with a lot of this AI technologies, things like ticketing, routing, and as I said, assistance, solving some customer queries, even automating some of the transcription work, taking in content and then extracting some pieces of text images, all those common areas which can be applied to any industry. So if you take an industry, for example, if you take again insurance, claims underwriting is another big area which involves a lot of content. Medical underwriting and pharma literature generation is another good area, and even customer support in the retail space, right? Those are interesting use cases. These are not, if you will, they are not traditional prediction machine learning use cases where we do things like, let's say, churn prediction or planogram optimization, things like that. But those traditional ML use cases can be combined with this new age generative AI use cases and provide a richer customer experience in the end. Okay. So again, moving on, looking at some of the building blocks, of course, I talked about a lot of technology elements, right? The logical stack, infrastructure, applications, data, etc., and with specific examples, use cases. But those things are not done in isolation. So we still have to leverage a lot of our partners. We can't build all the capabilities ourselves from scratch. So we'll have to leverage some of these partners at each area, right? Whether it is the hardware, whether it is LLMs, there are some frameworks which we use, and very specific frameworks which are used specific to fine tuning. I talked about vector databases. We use a lot of them specific to a customer. Some customers have preferences. For example, somebody might like Pinecone. I might use Chroma, things like that. And there is this whole gamut of uh, ethics, bias, and safety guardrails, extra around Gen AI, right? These were not existent before when we used to build apps. We didn't worry too much about bias of an application. We didn't worry too much about ethical safety, model safety, etc. when we built machine learning models. But they are now important because they are directly impacting the customer. So we'll have to leverage some of these other building blocks also. Okay, so when you start building these generative AI systems, there are different techniques. You can take an offensive approach or a defensive approach. The offensive, it's not offensive in the real term. It's about your strategy of building it more robust and trying to hit the market quickly. Where defensive is looking at the guardrails, looking at the ethics, looking at the biases, and then adding in more layers to be more protective, defensive, etc. Right. So on the left hand side, you'll see things like RAG and fine tuning. I'll explain them a little bit more. But on the defensive side, you would want to put in some guardrails basically, and then a lot of controls even before a query hits the generative AI system. In the UX itself, you can build in some controls. Okay, so these following slides I'll talk more about generic GenAI architectural patterns and more specific what we leverage day to day in our production systems, specific things, how do we implement in cloud, extra. So these are architectural slides. Bear with me for some time. I'll try to explain what each of them is. So the first one is a model, an architectural pattern where we just use an LLM provider, right? An LLM API, for example, Open API directly. You on top of it, you just build a mobile or a web UI, like a chatbot or any other interface, and then allow the users to query and then do the things they want to do. This is a very vanilla version of an architectural pattern. It's you don't know anything about what the LLM provides. It's just consumption of that API. The second model in an enterprise context, we don't generally do that alone. We bring in some controls, like for example, if you have to authenticate with a particular enterprise context, or if you have to leverage some guardrails from an LLM app store, we build some reusable components and then libraries also to use and build these reusable components. We leverage them in a mobile or web UI, and then again go back to a LLM provider, a public one or a private one, and then consume that, build an enterprise app, and then put it in an LLM app store. So this is the second architectural pattern. The third one is very interesting, right? We take a open source pre-trained LLM, you build this model on top of the existing LLM. You bring in your own data. You build two things. One is you build a knowledge graph to ground the LLM. When I say ground the LLM, as you all know, the LLMs might hallucinate a lot. It might talk some nonsense. But if you want to ground it based on the enterprise data which we have, you always try to use something like a knowledge graph or even a vector store, a vector database. Use techniques like either you use things like fine tuning or few shot learning, then you contextualize that LLM, use that LLM as your source for the API. Again, it goes back to the building the mobile web UI and talking to that fine tuned LLM or SLM, right? So this is the third model, which is a little bit time consuming because you'll have to do all this work yourself. That is not always required. The fourth model is what everybody uses now. It's called retrieval augmented generation. What essentially it does is you store all the data upfront in a vector database. You use grounded truth, and then you just augment your query with those data, right? Contextually, essentially what you're doing is you're searching first for some text which is probably relevant to the query, and then take that search output, paste it along with the prompt, send it to the vanilla LLM provider, and then you get a wonderful result which is grounded and probably more accurate and relevant. The last model which is emerging is all this. If you go back to the first slide which I talked about, right, the 7 patterns of AI, we talked about goal-driven systems, we talked about autonomous systems and agents. So that is the space which is evolving now. So there could be more than one LLM provider also. So there could be a mix and match of different LLMs, agents, etc. And how do these systems, different systems, co-work together, and then how these things can be orchestrated to achieve a common goal or an outcome. I sounded a little bit rhetorical, but imagine a real world scenario where multiple parties, multiple systems work together to achieve a common outcome, right? Something like building let's say, in the construction space, for example, right? Building a road, building a bridge, many parties coming together. There are vendors, there are raw material providers, there are project managers, there are architects. If you are able to emulate all of those functions as generative AI agents or systems, then if there is an orchestrator in between, and then if those goals are defined, these systems can co-work on their own to build a final output. That's the model which is evolving now a lot. It's also a threat and opportunity, right? So you can automate a lot of things which are being done now, but there are newer, bigger systems which will evolve now. Okay, more of the same, but this slide essentially in earlier literature, what used to be called as information retrieval now has become more relevant. Earlier, it used to be open domain question answering, but now with the advent of LLM and vector database, it becomes more interesting now. Okay, I will stop with some reference architectures. I will leave you with this 2 or 3 architectural frameworks. So this is what we use day in and day out for our production systems. We use LLMs at the back, the ones which I talked about, whether using a fine-tuned model or using retrieval augmented generation with a vector database. On top of it, we leverage a backend which is sitting probably in a cloud environment, a traditional web services or a microservices backend covered with an API and a lot of human intelligence leverages rules, and then the traditional serving, right, which could be web applications, APIs, or even mobile applications. So with that generic architecture in mind, there are specific architectures specific to a particular hyperscaler. In this case, it could be cloud, Google's cloud, GCP, where we leverage their foundational models from Vertex AI, Gemini, the likes of Gemini and others, and their vector databases. It could be also just a pure information retrieval system. So this is an interesting space where we have a lot of data. Our customers have a lot of data in their own databases, RDBMS, etc. So how do you look at not just content in terms of text, video, and voice, also look at enterprise structured data and then create some insights out of it. A lot of operational data which are very numerical and categorical sitting in RDBMS data, right? So that also can be, though it's a little bit tough in this space using generative AI, because generative AI more aligns itself to text and natural language, but we can also potentially leverage it for numerical data and data which is residing in traditional databases as well. Okay, the software engineering side. So as I said before, so across the life cycle, across the product engineering, software engineering life cycle, there are multiple use cases where we use Copilot, generative AI, the likes of all these tools which are embedded within IDEs. We can generate use cases, we can generate code, we can generate test cases, we can analyze code for efficiency, we can generate architectural views, and we can do CI/CD pipelines, and fundamentally change the support infrastructure itself. If you look at system integrators like us, we do support a lot of applications and systems, and that space is also evolving. There's a lot of AI ops, a lot of chatbots being employed, not just humans in the loop, not just humans who traditionally support tickets and incidents and things like that, but we also employ a lot of these techniques and tools for software development and also maintenance. So these are some examples of how Copilot does things. So you can actually do code translation, explain whatever you've written as code or existing code, generate test cases, fix bugs very quickly, which used to be a tedious task, improve the quality of code, things like that, which can be done very easily now. I'll skip this. This is more on the operation side. There was a layer in the logical stack around building the engineering pipelines. This is called LLM ops now. So you'll have to go through the cycle of building a model, maintaining it, and then fine-tuning it based on the real production, what is happening in production extra. So there's a lot of engineering work involved. This itself is a career path which many DevOps engineers, the likes of operational guys who will move from a pure DevOps engineering lifecycle model to a more of a LLM ops model also. So this is another interesting career path which is evolving. And let's talk about last but not the least, but the hardware play also, right? So I talked about pure play GPUs, NVIDIA GPUs, but there is also this lot of this new age hardware architectures which are evolving. Some of them, if you look at these two in particular, right, there is this company called Cerebrus, which has come out with a wafer scale chip. So the whole wafer is a chip, right? And it is employed in data centers now. The amount of throughput it can give in terms of generating tokens for generative AI, and also the latency which it can operate is humongous, and it brings down the cost also. So these are parallel architectures. These are not traditional von Neumann architecture. These are similar to GPUs, but at a much larger scale. And on the right hand side, you'll see some of these inference chips like Grok and Samanova. And if you see the numbers, if you see the graph on the bottom right, so Grok, for example, can output more than 240 tokens per second, whereas traditional let's say OpenAI or things like Amazon Bedrock, Azure itself, right? So you see both the latency and the throughput, the response time and the number of tokens it generates, number of output it generates is much more for a lesser price, right? Of course, there are some challenges to solve. How do we scale this to a larger token space, larger context, extra? But still, if you want to experiment on your own, you can try out, for example, this grok.com. You can just use any of the open source models which is there and see the difference, see the speed at which it generates outputs. That is pretty interesting. And all this is facilitated by the hardware and advancements which are happening. Okay, my last slide. So all this is good, all this is exciting, but you'll have to think about the planet, think about the humans as well. So these are the set of sustainable development goals from the UN. Of course, this takes a lot of compute power, and that means a lot of data center leverage, a lot of electrical power consumed, a lot of emissions being generated. We talk about sustainability, we talk about carbon emission reduction. Our company has a goal of reducing our carbon emissions by 50% by 2030. But all this is not possible because technology is also growing. We have more and more consumption by these large language models. This is a prime area for academic research also, right? If someone can come up with a model which is very energy efficient, which may consume just 2 watts of power per hour, but can still produce the output we want, that's an interesting space to look at. So we'll have to think, though these exciting technologies are there, we'll have to think planet first and then be sustainable in this space as well. So thank you. I hope I have conveyed what I wanted to convey, both from an evolution, academic architectures, and also from an enterprise perspective. What are the use cases? How do we really put these systems in production and then scale it out? Finally, be sustainable in this whole new development also. So thank you for this time, and I'll be open to any questions which I can take. Kavya, you are on mute.
Thanks, Senthil. I'll just, it's open for questions. We already have 3-4 questions. I'll just take a couple of them online. Yeah, as you can see, Anjit and Bharadwaja have given in the questions. And we also have 2 questions on the chat. So you can take the questions in the Q&A first, Senthil. How Gen AI helps change jobs in healthcare?
Sure. So healthcare, if you look at the value stream, right? So healthcare, there are 2 broad industries, I would say. So the healthcare providers are there, which are basically the hospitals, and then healthcare payers are there. The payers are basically the health insurance companies, right? So if you look at the job profile, if you take the payers, the provider space, which are basically the hospital jobs, it could be a doctor, it could be a nurse, it could be a GP, physician, or a pharmacist. The fundamental thing which will change is there. For example, as I have my dentist friend who talks about keeping records of all the customer and the operations and the surgery is done, right? But if he wants to look at the patient again, if there is an appointment he has with the same patient, he has to refer back to that same context which is and history which has been generated over time, right? So that is a good area for him to look at leveraging Gen AI, right? Make no mistakes also, by the way, right? Be more accurate, be more precision, be more customized to that particular patient. So that is another way in which he can operate. But if you look at in the provider space again, if you look at maintaining records and even providing some amount of customer support, we all know that scheduling an appointment is a big problem in the healthcare space, right? So you won't get appointments. Scheduling is a big problem. So that is another good area, though it falls in the traditional operational research space. This can easily be done now with virtual assistants, chatbots, etc. Though there are some health advisory assistants which are now available, you'll have to take them with a pinch of salt. I read a story only yesterday that one kid in somewhere in Netherlands was able to self-diagnose himself instantly after waiting for 5 years to get a proper diagnosis. So though that is interesting, it has to be taken with a pinch of salt, right? How accurate it is and all. But that space is evolving. On the payer space, if you look at the insurance space, these technologies can be used to fast track some of your claims, for example, because processing itself can be done pretty quickly. It's a very content intensive space. They'll have to look at a lot of history, they'll have to evaluate your claim, they'll have to underwrite, so on and so forth. So that will probably get speeden up, but not the same process will continue, I would say. Right? So that's the way jobs will change. Jobs will not go away. More interesting jobs will get created. That's my optimist view of seeing things in the generative AI
Yeah,
space.
absolutely. Not just in healthcare, I think in any industry that would be the case.
Yeah.
We also have some other questions. I'll just read it out. So one of our professors, Bharadwaja Kumar, has asked that they are working on auto evaluation of answer scripts of students. We have evaluated a lot of models for this task, and we have observed a lot of variance in the performance of different models in producing scores for written essays. As far as I understand, LLM behaves based on the data they are trained, but are there any other things? Please give your views.
Yeah, I think we also face similar challenges. Uh, so we also go through this engineering process of evaluating different models, because the way they have constructed, they have been constructed is based on the data and the mechanism with which they are trained. But the variance can be controlled using some fine tuning parameters. The variance can be controlled using ground truths, right? For example, if you have evaluated, if your own way of evaluation, right, has yielded some results, and if you want to conform to those set of guidelines and rules, you can codify them as ground truths either in a vector database or in a knowledge graph, and use that as a reference, feed that into a model to control that variation. It's not a yes or no answer, but there are engineering principles which has to be applied to get to a level of accuracy with which you want to score on, right? That in essence, that's why I'm saying all these top stacks are there, right? The foundation models are there. There are different models. You'll have to select them first, maybe narrow them to one or two or three, and then use them at a base to do this fine tuning work. Generally, I say fine tuning, but there is a lot of work around fine tuning parameters, fine tuning the ground truths, and then making sure you get what you want, right? So maybe we can take that as a follow up, right? And we can do some work along with you if you want, if you're interested.
Sure.
Okay, the next question is, what is the accuracy of generative AI in comparing human manpower or human interaction while handling ambiguous or tough situations? I think, yeah, I think if situational awareness is something, if that's what you're talking about, things like somatic intelligence is still not there, right? Psychosomatic intelligence, all those things are not there. It's still, I would say, a system which is blurting out probabilities. Situational awareness, intelligence, all those things might already be there. They have not been released to the market. You saw some glimpse of those things in the recent announcements, but I think there is a lot of this autonomous AI, AGI, SGA things which are evolving now. It might take some more time. I still think it is not there yet, or they are there but they are not released yet. Okay. And there is this question of automation of image analysis, patient monitoring, evidence-based recommendations. All these are being done now. Patient monitoring, if there is a video feed or if there is even a data feed, we have worked with customers who have equipment inside ICUs, right? It's a good example where each parameter, each health vital has to be monitored real time in an instantaneous fashion. All those, it's a combination of things, right? It's not just pure AI. It's all about instrumentation, IoT, and then also rule-based systems which can provide this evidence-based recommendations also. Okay. There is a question on how GenAI can help in cybercrime process. Yeah. We haven't worked specifically in this area, but since the word cyber is there, we have worked in pattern detection for cybersecurity, which same can be translated to the cybercrime area if there are instances of or patterns of cybercrime which can be detected easily, right? It more falls in the traditional AI space. Still, there are these techniques, the models which are used are the same, but it's not probably in the generative AI area, but more in the traditional space. That area is also probably evolving. Okay. How to incorporate AI and robotics in medical diagnosis? What is future scope real-time data set available for this topic? This is an interesting area. Our healthcare team is setting up a lab right in this building which I am sitting. They are looking at bringing in a combination of robotics, and they are using, for example, of course, data set is a problem, which we all know, and uh, econometric data and then longitudinal data is also tough if you want to generate a history for a particular case, for a particular patient. It's sensitive, things like that. But one other technique which can be used is synthetic data generation, which we are trying out now. Diagnosis, yes, I quoted that example. It is out there, but again, how accurate it is a question which needs to be answered further.
Senthil, there are also a few questions in the chat. I'll just quickly read them. In your perspective, are there any job openings for prompt engineers? I think yes, but if you would like to add a few more points on this, please.
Yeah, so it's not just prompt engineers, it's also about people who can understand the full stack, right? So then prompt engineers are uh, people. So I'll take this example of Google search, right? So initially, when I started in this industry, I leveraged Google a lot because of 1999, so to speak, right? To do many things, right? To fix code, to find out newer ways of design, things like that. Now, to do the job itself, we are asking a lot of questions to the chatbot, right? And different ways and different means you ask, the output is different, right? So that is the core prompt engineering skill set, the way you ask, the way you construct your prompts. But the prompts itself doesn't make sense if you don't understand what the stack is, right? So a combination of the stack knowledge, the engineering knowledge, as well as prompt engineering will yield you a job, right? That's where we look at this full stack candidates in this field.
Got it, Senthil. Could you also suggest some LLM model suitable for students and researchers?
I would say stick with some open source models, because where you have some control over the weights and parameters which you can fine tune. The weights are also provided to you. The things like Llama, Mistral, and there are some other small language models also are very interesting to look at.
In that context, I might also add what other tools can you suggest everyone to use? Like, of course, everyone is using ChatGPT. And like you mentioned in the presentation, summarization, such as Read.ai or any other tool such as that. But other than these known tools, are there some other tools that you can suggest that could make life easier for everyone?
Yeah, so you will have to probably change the notion of looking for LLMs and then looking for applications using LLMs, right? So if you just ask some of these uh, Gemini or Copilot, things like that, there is like a plethora of tools to generate PPTs, write, let's say, SOP, create academic research, for example, very specific, very customized for the function of work you want to do. Image generation, another example, right? I don't want to name a particular tool because there are thousands of tools for
Yeah,
each function. And there are some sites I can probably later I can share, right?
sure.
Which rank based on the alignment, the effectiveness of those tools, right? Basically, they are like a recommendation engine for those tools.
Yeah.
So you can
Oh,
use some of
great,
them
great.
actually.
You can share with me. Maybe I can share it with the group who participated today. Just last few set of questions. What is the exact role of RLHF?
Yeah, reinforcement learning with human feedback was used initially for by the OpenAI team to to make that alignment properly, right? I talked about alignment, attention, and all that. So what essentially was done, I probably, since you're mentioning the term, I'm assuming that you'll know the semantics behind it, right? It basically had a set of humans actually validating the model output, saying this is right, wrong, and then grounded that output, and then that was fed back to the vanilla model, right? So it's more of a human feedback which grounded the system a lot, and then the final weights were managed using this RLHF technique. That is not something which we do. It's not easy to do also in an enterprise context, because you will need a lot of those experts to sit with that model, and it takes a lot amount of time to even fine tune. Now, what we typically do is to achieve that level of accuracy is not easy. It is very costly also, because you have to spend hours of training with the humans also, right? So what we typically do is all this easy techniques like RAG and simple few shot learning things like that, right?
Got it.
You don't always build a ground up LLM for any problem. Though for one of the areas we are partnering with Google, we are building a ground up healthcare LLM because we have a huge product in the healthcare space. We have the data for the Medicare and Medicaid in the US. So there we are building a ground up LLM for our.
Oh, wow, nice. Great to know. One other question: is a product that is built on OpenAI, is it better than one building with OpenGPT and Hugging models?
Yeah, it's an interesting question. So we as neutral SIs, we'll never say this model is better or worse, but it depends on the context again, right? If you are able to do these things, break open a LLM and then do some fine tuning, I would still say go with the Hugging Face. But if you are trying to build an application quickly to your customer, then the easy way out is to use some of these hyperscaler provider tools because they also not provide only the LLMs, they also provide, sorry, GenAI studios. You don't have to write a lot of code. You can just upload your data, create that workflow conversation, and then deploy an agent very quickly. So building apps means leveraging hyperscalers is very easy to do. But if you want to do more customization, more stuff, fine tuning extra, go with open source cloud.
Okay, I think we've already overshot a little over the time. So if there are any questions, will it be okay if I drop your email, Senthil?
Absolutely,
If
absolutely.
anyone is interested, you can please
Sure.
write to Senthil with your additional questions.
Yeah, we cooperate. We work with a lot of colleges through our regional academic council. So yeah, and we work with students also directly. If you are interested to develop some use cases, we can bring in those use cases. Your students can build, and we can coach them. Not in an intense fashion, but we can mentor them to an extent.
Okay, got it. So, since we are shooting a little over time, I've just dropped Senthil's and my email IDs in the chat to all the participants. You can please drop in your emails with your questions, or if you have any particular, further, if you want to work with Senthil, you can please drop that. Meanwhile, I'd just like to take this time to thank you so much, Senthil, for a brilliant presentation and also answering so many questions, giving so many insights, including use cases, which I think is more pertinent because, anyway, professors, they are already experts in conceptual basis. Getting
Yeah,
to
that was one
design.
thing I was afraid of, right? Explaining a fundamental architecture to professors. Hopefully, I made my case today. I think thanks for your patience, and then more importantly, taking time out of your busy schedule to attend this. And I'll be more happy to interact and collaborate in the future also.
Yeah, thank you. Thank you so much, Senthil. Thank you to all the participants for taking their time out. We'll soon come back with another interesting session. Looking forward to meet you all again. And same with you as well. Looking forward to continue working with you, Senthil. Thank you so
Thank you.
much. See you all. Have a good day.